integration. And contour integration means that we can use Cauchy integral formula, close integral C f z dz, and that is 2 pi I sum over residues. So why you need a sum? Because suppose this is the contour, so there will be few poles. Suppose there are many poles, 4 poles. Suppose there are 4 poles, and 3 of them are inside this
Sir?
contour.
So the board is not properly visible.
Sorry?
The board is not properly visible, sir.
To everyone?
Yes, sir.
Yes, sir.
थोड़ा blur है, sir.
Blurred.
Why?
बोले सर हाँ ठीक है सर बीजू बोले सर
Now it is okay, sir.
Now?
No,
Yes, sir.
sir. Yeah.
Visible, sir.
क्लियर है सर
वो चौक शायद उड़ के कैमरे के ऊपर लग. Okay. Now board is visible properly?
यस सर
Okay.
Yes, sir.
Yes, sir.
So suppose this is the contour, and this contour may be anything, ellipse, circle, any closed contour. Closed contour. Okay. And there are poles which lie inside, and there are poles which lie outside. So suppose corresponding to Z0 residue is R0, corresponding to Z1 residue is R1, corresponding Z2 residue is R2. So the integration will be 2 pi I. Sum of residues means R0 plus R1 plus R2. Okay? This will be the sum of residues. And also, if suppose on some contour, the pole lies on the contour, then your integral C fz dz will be pi I sum of residue. So pi I into this residue. Okay? So here it is 2 pi I, and here it will be pi I. Pi I into sum of residue. If the pole is on the contour. So this case is on the contour. On the contour. But outside the contour, it will not be considered as pole. So pole will be only considered within the contour. If your pole is outside the contour, that will not be treated as a pole. All right. So this is the contour integration that we are going to discuss right now. For any complex function and for any contour, we can apply this formula. This is known as Cauchy integral formula. This is known as Cauchy integral formula. All right. So let us solve few questions on this. Is this okay?
यस सर
Yes, sir.
So in every question, we will have to calculate the residues, and the method of residues I have already told you. So you can revise the calculation of residue in almost every question. So that should not be a problem, because ultimately we will learn how to calculate the residues. Okay. So let me take integral. It is like this. Integral z e to the power I pi z by 2 upon z square minus 1 and closed contour is gamma, and gamma, the contour is given like this. It is given like this. This is gamma, the closed contour, and the values minus 1 and 1 are given like this. Okay. Now please understand, our fz here subjected to the integration is given by I pi z by 2 over z plus 1 and z minus 1. And if you see this contour, it will be coming like this, this, and going like this. This is the origin. So I may consider the gamma as made up of two contours, C1 and C2. Like if I can take this as C1 close contour and this as C2 close contour. All right. So like we break the limits, I will break here gamma fz dz is equal to gamma C1 fz dz plus gamma C2 fz dz. Okay. So now C1 is a counterclockwise or anti-clockwise. And this C2 is clockwise. It is clockwise. So C1 will demand 2 pi I into residue. Let me call that residue as R1. And C2 will demand minus 2 pi I into residue. Let us call that R2. This much should be clear.
Yes,
Yes,
sir.
sir.
For this C1, 1 is lying inside. And for this C2, minus 1 is lying inside. So if I calculate the residue R1, that will be given by limit z tending towards 1, z minus 1 because it is simple pole, e to the power I pi z by 2 upon z minus 1, z plus 1, and this will be 1 by 2, and z is equal to 1, so it will become
सर z आएगा ना फंक्शन में f of z में z है ना z into e raised to I
z. Z is also there. Okay. So it will become, this will cancel. It will become e to the power I pi by 2 means iota. So it will become iota. R1 will be equal to iota. And R2, will be limit z tending towards -1, z plus 1 into z e to the power I pi z by 2 by z minus 1 z plus 1, and z plus 1 gets cancelled, and if you put z is equal to -1, we get minus I by 2. -1 minus and minus cancels now,
Yes, sir.
and minus I pi by 2 will become
Minus I by.
minus I.
Yes, sir.
So it will become minus I by 2. So this will become 2 pi I into I by 2 minus 2 pi I into minus I by 2. So this will become plus. So it will become 4 pi I into I by 2, which is minus 2 pi. चेक करो एक बार.
Yes, sir. आ रहा है
सही
सर.
है सर, आ रहा है.
Any step is not clear, so you can ask. Clear है भाई?
Yes, sir.
Okay. Now let us take another question in which we have a contour integration C sin z upon z plus 4 iota z dz, and C is mod of z minus 4 minus 2 iota is equal to 6.5, like this. Now please understand, if some equation like this is given, z minus z naught is equal to r, that means your circle has center
At Z0.
z naught and radius is r. R is the radius, okay? Now please understand, if you take any point z inside this, so this length should be less than radius. Are you understanding that? And if this z will be outside, this length will be greater than radius. This is very simple to know whether your point is inside or outside. Yes?
Yes, sir.
So first of all, calculate the pole, that is fz is equal to sine z upon z common 1 plus 4 iota. This is your function. So that means z is equal to 0 is a pole. Okay?
Yes, sir.
So if you see for this z is equal to 0, let us see what is this length equal to, whether it is greater than or less than 6.5 using this concept. So this is under root of
120.
16 plus 4 root of 20.
4.47, sir.
So root of 20 है ना?
Yes, sir. .47, sir.
So
Magnitude.
that means this is inside this contour. This 0 lies inside the contour. And what is our integration equal to? This will be equal to 2 pi I into residue. Residue is limit z tending towards 0, z into fz, which is sine z by z1 plus 4 iota. So this will give you 0. Because sine 0 is 0. So dekho, this is again a simple pole. What is residue at simple pole? Limit z tending towards z0, z minus z0 into f of z. Yes? ये सबको समझ आया?
Yes, sir. Yes, sir.
How to see that your pole is inside the contour or outside the contour? So you don't need to draw the contour, just take that point, take that length. If that length is small than radius, then it is inside. If that length is larger than the radius, then that point is outside. So because root 20 was less than 6.5, that's why I considered it inside. Okay. दूसरा लें?
Sir,
Yes.
here the function is analytical, right? As
No.
we can
No.
reduce it to remove signs, and we can write as.
So it has removable singularity.
Yeah.
But it is not analytic.
Okay.
So once you open this sign and then at z is equal to 0, you will see that b1 is equal to 0, right?
Yeah.
Yeah, you are right. Because if I expand this, the first term will become 1, right?
Yes, sir.
If I expand this, so it will become 1 by z will become 1, and then 1 by 1 plus 4i. If I expand it for z is equal to 0, so b1 is not there, because first term will become 1, then
Z
z
square by
square
3 cube. 3 factorial.
plus dash dash dash. Correct?
Yes, sir.
Yes, sir.
Okay. Next one is like this. Close integral c z cube dz upon z square minus 5z plus 6. And the contour is a closed contour 2 mod z minus 5 is equal to 0 counterclockwise. So what is our contour? Mod z is
5 by
2.5. That means it is like this. C 2.5. ठीक है? So your fz will become z cube upon what will be the roots? Minus b plus minus under root b square minus 4ac upon 2a. So it will become 5 plus minus 1 by 2. So it will become 3 and 2. Correct? hai?
2. Yes, sir.
Yes, sir. 3 and 2.
So it will become z minus 2 and z minus 3. Okay. So 2 will be here and 3 will be here. So only 2 will be considered because 3 is outside the contour. So what is residue? At z is equal to 2. It will be limit z tending towards 2, z minus 2, z cube by z minus 2, z minus 3. This will cancel. It will become 8 by minus 1, that is minus 8. And the value of integration will be 2 pi I into minus 8, that is minus 16 pi I. समझ आ रहा है सबको?
Yes, sir. Namaskar.
Yes, sir.
कोई भी डाउट हो तो पूछते रहना. So here also residue at simple pole was used. Shall I proceed?
Yes, sir.
Now let us put 1 over 2 pi i's. You have to calculate this contour integration e to the power 4z minus 1 upon cos hyperbolic z minus 2 sine hyperbolic z. Okay, and circle is mod of z is equal to 1 counterclockwise. This is the contour, this is the question. So please understand, as soon as you see, I told you, you see lot of hyperbolics in the numerator and denominator and exponential functions. We can't write an infinite series, Laurent series for this. We can't, this is not a simple pole. So only thing that work here will be fz is equal to phi z by psi z thing.
Right.
Only this concept will work here. But for that, we will have to first of all see what are the poles and where they lie. So our contour is very simple. It is just a unit circle like this. This is our contour. Now contour is this, and for poles, we put cos hyperbolic z minus 2 sine hyperbolic z is equal to 0. Yes? So this will give, क्या आ जाएगा? Cos hyperbolic z is equal to 2 sine hyperbolic z. That means tan hyperbolic z is equal to how much? 2. Yes or no? 1 upon 2.
Yes, sir. Yes, sir.
So we will have to see e to the power z minus e to the power minus z upon e to the power z plus e to the power minus z is equal to 1 by 2, or e to the power 2z minus 1 upon e to the power 2z plus 1 into 2 is equal to 1, or 2 e to the power 2z minus 2 is equal to e to the power 2z plus 1. Yes or no? This get cancelled, and e to the power 2z is equal to 3. Yes?
Yes.
So what is the pole? E to the power 2z is equal to 3. So what is e to the power z? Taking root on both sides, na?
सर लॉग ले लेते हैं, ln 3/2 आ जाएगा z की वैल्यू, and e to the power z equals to √3.
एक्चुअली जनरल वैल्यू आएगी, समझ रहे हो?
ओके सर.
वो तो एक फिक्स वैल्यू जैसे ना प्रिंसिपल वैल्यू हो गई.
3/2.
So what will be e to the power z is equal to?
√3.
1
no.
plus z.
लॉग ही ले लेता हूँ. 2z is equal to, वैसे मैं अगर दोनों तरफ रूट ले लूं तो e to the power z will be equal to plus √3 and minus √3, right?
Yes.
तो 2z z is equal to कितना आ गया?
ln 3/2.
ln 3/2.
2z is equal to ln 3, so z is equal to 1/2 ना? ln 3.
Sir.
Yes, sir.
And there will be another value also. What will be that? E to the power z will be equal to minus √3 also, na?
Yes, sir.
So that will give imaginary value. Log of negative number will be imaginary.
ln 3 plus I/5.
So what is this ln 3? What is ln 3?
न्यूमेरिकल वैल्यू सर.
Hmm.
सर इसको ऐसे ही रहने देते हैं ना, सॉल्व करते वक्त आसान पड़ेगा.
अरे पहले देखोगे तो कि अंदर है भी कि नहीं.
अच्छा, इनसाइड. यस यस.
1.098.
सर.
1.09.
1.09.
9.
So what will be this?
0.549.
0.5.
549.
So that means it is somewhere here. At this you are getting a pole. Yes or no? So ultimately तो I will have to see the value of z ना कि वो कहाँ lie कर रहा है. Is it inside or it is outside? That is something to be seen. And यहाँ पे मैं अपना वाला मेथड भी लगा सकता था. Like please see, e to the power 2z was 3, right? So if I just want to see the different values, यहाँ पे 1 है ना, तो 1 को मैं e to the power में लिख सकता हूँ and then I can get the different values, right? So like e to the power 2z is 3 into e to the power iota 2n pi, correct?
Yes, sir.
And this 3 can be written as e to the power ln 3 plus I 2n pi is equal to e to the power 2z. So z can be written as 1 by 2 ln 3 plus iota n pi. This is possible general value. Yes or no?
Yes, sir.
So for n is equal to 0, you got z is equal to 1 by 2 ln 3. That is the value that lives inside. And for n is equal to 1, this value is how much? 0.5.
0.54. Yes, sir.
5, 4.
Yes, sir.
And if I take the next value, z1, where it will go? 0.54 plus I pi, right? Yes or no?
Yes, sir.
So what will be its mod? Under root of pi square plus 0.54, which is greater than 1. So that's why it will go outside. और इसके बाद वाले सारे outside चले जाएंगे.
Sir, z is equal to 1 by 2 ln 3 plus I2 n pi था.
What? Sotan?
Sir, आपने जो लिखा z is equal to half
हाँ
ln 3 plus I2 n pi था.
हाँ 2n pi.
तो उसके नीचे
यहाँ n pi हो गया.
सर कैसे?
सोचो कैसे?
सर
ये तो
सर टू ने तो डिवाइड किया था.
सोचो जरा कैसे हुआ होगा.
ओके सर, ब्रैकेट नहीं है, मैंने ब्रैकेट लिख दिया था.
आया
ओके
समझ?
सर, गॉट इट. ओके सर, मैंने ब्रैकेट लिख के किया था.
Okay. Now you have only one pole, that is z is equal to this, or the pole may be written in this form also, that e to the power z is equal to what? Here we can write now e to the power z is what? ln 3. Z is equal to e to the power 2z is equal to ln 3, right? Okay or not?
Yes, sir.
The same thing can be written like this also, no? Okay. So
Yes.
now can I erase all this?
For e raised to 2z is 3 na?
E raised to 2z is 3.
3 na sir.
3, yes. So 2z is equal to ln 3. So z is half ln 3. Okay.
Okay.
Now let us get to this. Fz is phi z upon psi dash z. मतलब sin hyperbolic z minus 2 cos hyperbolic z. Yes. So convert this into exponential. So I mean, I want residue, so I am putting limit e to the power 2z goes to 3. So let me put this also, e to the power 4z minus 1 upon, what is this? E to the power z minus e to the power minus z by 2 minus e to the power z plus e to the power minus z. So this is e to the power 4z minus 1 upon e to the power z minus e to the power minus z minus 2 e to the power z minus 2 e to the power minus z by 2. So that will be multiplied here. Simple algebra है, इसको देख के नहीं घबराना है. So what is going to happen?
Sir, f of z is in the denominator. You have changed the order, sir.
This is not f of z. Now I'm in the process of
F of
calculation of residue.
derivative.
So this will become what? 2 times e to the power 4z minus 1 over what it will become? Minus e to the power z, and this one minus 3 e to the power minus z. Yes or no?
Yes, sir.
And this will go to become minus 2 e to the power 4z minus 1, and if I take e to the power z, it will become e to the power z upon e to the power 2z minus 1. Is this correct? Minus 3. Yes? Yes or no?
Yes, sir.
So what was e to the power 2z? It was 3.
3.
So it will become minus 2, 9 minus 1, root 3 upon 6. बोलिए. 2 and
Yes, sir.
3. So what it will become? Minus 8 by root 3. And integration will be 1 by 2 pi I into 2 pi I into residue minus 8 by root 3. It will cancel. So this is the answer. So this is a very nice example to understand the residue being phi z by psi dash z. Now ask if there is any doubt. These algebra should be done by yourself. Do it each and every step. That will give you a lot of confidence. And ये hyperbolics, exponentials, इन सब चीजों की dealing आपको अच्छे से आनी चाहिए. And that can be learned only from the question. That can't be learned in general by reading it. Only by doing the problems, you will get a hold on it. Anything anybody wants to ask? No, nothing?
No, sir.
बाकी लोग भाई बताओ।
नो
क्लियर है
तो क्लियर है।
चलो वेरी गुड। Now closed integral tan z over z square minus 1 dz and mod of z is equal to 3 by 2. Let us do this. So first of all, what is the function? Tan z over z plus 1 and z minus 1. Also sin z over cos z, z plus 1, z minus 1. This is the function. And if you want to see the poles, they will be 1 minus 1, and also when cos z becomes 0, that is z is equal to pi by 2 minus pi by 2, 3 pi by 2 minus 3 pi by 2, like that. On these points, cos will become 0. So the poles will not only come from the denominator, but sometimes from the numerator also. So you have to be very, very careful about it. And how is our circle here? It's a circle 0. This is 1.5. This is 1.5 iota, like this. This is the circle on the Argand plane. Now 1 is here, obviously minus 1 is here, but next point is pi by 2. Pi by 2 means 3.14 by 2. What is that? 1.57. So this will go outside, and here minus 1.57, this will also go outside, and others will be obviously outside. So only two poles lie inside the contour, so only they will be considered. This cos thing will not be considered as it goes outside the contour. So get the residue. Residue for z is equal to 1. First of all, it will be z minus 1, limit z tending towards 1, fz, which is tan z by z plus 1, z minus 1. It cancels and it will become half of tan 1. And similarly, residue for z is equal to minus 1 will become limit z tending towards minus 1 and z plus 1 tan z by z plus 1 z minus 1. Z minus 1 will give you again tan 1 by 2, because tan of minus 1 is minus tan 1. So the answer will be 2 pi I sum of residue, half of will become tan of 1. This is the answer. बहुत ही अच्छा क्वेश्चन है. अगर इसको थोड़ा सा सर्कल बड़ा कर दूं तो बहुत अच्छा क्वेश्चन बन जाएगा, राइट? यू कैन डू इट एज
रेजिड्यू एट z minus 1 पे minus 1/2 10 1 होगा।
सॉरी एक बार फिर से।
सर ये रेजिड्यू z minus 1 पे माइनस हाफ नहीं होगा सर?
tan 1 भी तो है,
हाँ
तो ये क्या बन जाएगा? tan of -1
यस सर
by -2 which will become again half tan 1. ठीक है?
सर
Anything else? Anything else?
No, sir.
तो एक टाइप का कंटूर इंटीग्रेशन जो बेसिक है, कंटूर इंटीग्रेशन fz dz is equal to 2 pi I sum of residue, that I have done. And now we will move to next type of integrals. Our actual aim is not to solve complex integrals. Our actual aim is because we encounter real integrations while solving Schrodinger equations, while solving electromagnetics, while solving statistical mechanics, we encounter real integrals which are tough to solve. So our real interest is, can we use this complex analysis to solve those integrals? So in next class, I will solve real integrals using complex integrals. Okay? Yeah. Thank you so
sir.
much. Good night. Good
Thank you,
night.
sir.
Thank you, sir. Good
Thank
night,
you,
sir.
sir.
Good night.
सर
हाँ, राजकिशोर कुछ कह रहे हो?
No, sir.
Okay. Good night.
Good night, sir.